Okay, so these are the notes for Integrated 2, 5.2.1. We have perfect square equations, so directly from the notes here, and then a couple of examples as well. When we have a quadratic equation where we can actually rewrite it as some parentheses or some quantity squared, so back up here in that x minus p quantity squared, that's the big thing. And then on the other side, you want a constant. So q is just some number. So just to clarify here, both of these, so p and q are just numbers. So p and q are real numbers. All right, so then we have this situation, so we'll give this x plus 3 squared is equal to 28. So it kind of looks something like that. What we want to do is take a look at these types of problems and see, without like rewriting and manipulating the entire equation, can we actually try to figure out what we think the solutions might be? So let's go ahead and inspect these three. So it is set up as a perfect square form. You notice on the left-hand side, we have an entire quantity squared. So x plus or minus some number inside. And then on the other side of the equal sign, we have just a constant. So back in Integrated 1, one of the things that you guys did was the idea of kind of like looking inside or undoing or rewriting. So I really want to kind of step back from this, and instead of really like diving in and trying to solve, I want to stop and think about this. Basically what this says is that there is something. So I'm going to refer to all of this stuff inside with the squared as something. So basically there's something, so I'll call it question mark, that when squared, bring that squared down, I get 4. Okay, so let's think about what those somethings could be. All right, well, I know that if I take 2 and I square it, I get 4. So maybe that something is 2. That's possible. So that's one thing that could be the case. But then maybe that something, let's see, could also be negative 2, because I know that negative 2 squared would also work. Okay, so here I know that the thing, whatever it is, that when squared gives me 4 is, well, could be 2 or could be negative 2. So now we can actually start like manipulating this. Well, the question mark, well, go back up to the question. I called it x minus 1. So I replaced everything inside the parentheses. So maybe the stuff inside is actually equivalent to 2. Well, if it is, we go ahead and solve, and we get x equals 3. So I think that's one of the answers that would actually make this true. Okay, but I have this other question mark. Well, remember I called the question mark x minus 1, so the thing inside. Well, maybe it's negative 1. All right, let's go ahead and move the 1 to the other side. Okay, so I believe that if I go through and I actually solve this problem, like algebraically manipulate it, if I plug in x equals 3, or if I plug in x equals negative 1, I can actually get it to work. So I'm just going to do a quick check on it. So let's go ahead and plug in 3. So this is just a check. That's all I'm doing. So if I do 3 minus 1 squared, is that, put a little question mark over this, is that equal to 4? Well, I think so. 3 minus 1 is 2, and 2 squared is definitely 4. So I think I get a true statement here. Okay, so x equals 3 worked. All right, let's check the other one. So maybe it was negative 1. So if I do negative 1 minus 1 squared, is that equal to 4? Well, I think so. That's going to give me a negative 2 squared, and I know that negative 2 times negative 2 is definitely 4. So actually both of those are going to work for me. So it's the idea of not necessarily like trying to get your hands in there and algebraically manipulate this or twist this thing to your will. We just want to stop and think if it's even possible. So if it's not possible, then why would we continue with it? So let's see if we can approach the next one the same way. So if I look inside, all right, so it is set up in this perfect square form. So something, I don't know, the thing inside, something squared is going to give me 0. Something squared gives me 0. Well, the only thing squared that gives you 0 is 0. So something squared is equal to 0. Well, the only number that when you square it gives you 0 is 0. All right, so, but we know that the question mark, well, that was the x minus 1. So let's replace that, my something, x minus 1 equals 0. All right, let's go ahead and solve that. So I get x equals 1. I'm not going to get another answer here. 0 is very special for so many different reasons. So in this case, I know the only thing squared gives me 0 is actually going to just be 0. All right, let's take a look at this one. So let's sit with this for just a second and see what you think. Follow the same idea, same process. All right, so the exact same thought process here. It's set up in perfect square form. I've got something, well, it just so happens it keeps being x minus 1. It doesn't have to be. It could be like 3x plus 7. It could basically be anything. So something, I don't know, I'll call it question mark, something squared is equal to -4. Well, not with the numbers that we're familiar with at this point. So far, I would say no to this one, so far. And really, it's because all of the numbers that you are familiar with up to this point are real numbers, like fractions and decimals and positives and negatives and zeros and big numbers and small numbers, all sorts of different stuff. But I don't think that your current knowledge is going to allow you to say that a number that you know of right now, squared, is going to be equal to -4. And really, the kicker here is that negative sign. So I'm not going to say it's impossible. I'm just going to say that there's no real solution here. And I really do want to focus on the real part of it, because all of the numbers that you're familiar with at this point are real. Now, that's going to change pretty soon, but at this point, it's not real. So based off of my current knowledge, I think that would actually be my answer, is no real solution. Now, we're going to learn and grow and do some new stuff with being able to hopefully solve this in the very near future. Okay, moving on. So let's take a look at question 1 and 2. Now, some of this is going to be a little bit obvious because we know the whole idea of that something squared is equal to 0. Okay, well, that's 0. Something squared is equal to 4. Well, okay, that's 2 and -2. It becomes a little bit trickier when it isn't necessarily a number that we know off the top of our head. But I think we can do number 1. So why don't you take a minute, see if you can get the answers for number 1. Then we'll talk about number 2. Okay, so here we go. We're actually able to, well, because it's 9, and the numbers that we've looked at so far, they all have something in common, except for that -4 on the previous page. We could do 0 because we know a number squared equals 0 was 0. We could have done 4, which we did, because we know that 2 squared and -2 squared gave us 4. Now we can do 9. I think the reason why we've actually been able to approach these problems this way is because the thing that it's equal to, so this 9 or 4 or 0, they were all perfect squares. So square roots that we know off the top of our head. So if it was 16, okay, it's 4 and -4. If it was 36, all right, it's 6 and -6. Those are all things that we're comfortable with or familiar with. And the next question, it's not that it's impossible, it's just that we might not know exactly what the square root of 7 is going to be. So I think I want to approach this in a different way. I don't want to think about this without doing any actual, getting your hands in there dirty and trying to solve the equation. So I want to think about actually solving this algebraically. So my goal here is to try to get x equals. In order to get x equals, just like any other equation, your job is to peel all of the things away from x. So let's think about what we've got going on here. So I have x is trapped inside a set of parentheses with a plus 5. Okay, well, the 5's got to go at some point. But I got to get rid of the parentheses to even get to the x. But I can't get rid of the parentheses unless I get rid of the squared, because the squared is attached to the outside of the parentheses. So see, what I'm thinking is I want to take a look at where x is in the equation, and I just kind of chip my way out. So yes, I know I'm going to have to get rid of the plus 5, but I can't get to the plus 5 because the parentheses are in the way. But I can't get rid of the parentheses because I have an exponent attached to it. So it's like all these different layers of things that I have to deal with. So what I'm going to do is I'm going to start with the thing that's on the furthest on the outside first. So if you're trying to take the layers off of something, you got to peel the outside layers off before you can even get to the inside layer. So let's peel off the layer that's furthest on the outside, which is the squared. So I'm going to go ahead and take what I've got here, and I'm going to have to peel off the squared first. So I got to think about, well, how do I get rid of a squared? What's the opposite of that? Well, it's kind of what we were doing. If you want to take the opposite of a squared, you're going to have to square root. So to get rid of that 2, I am going to have to square root everything on that side, since the square and the square root are inverse operations of each other. However, you know, if we take the square root on one side, well, whatever you do to one side, you're going to have to do to the other. So I'm going to square root that side as well. However, I'm not quite done just yet with the square root part of it. It's important to note that when you square root a number, technically get 2 answers. You get a positive answer and you get a negative answer. Just like, so I'll do a little tiny bit of side work here. If I wanted to have a 4, so super basic, and I wanted to square root that 4, well, you know that if we square root 4, so we did it on the previous slide, you technically get a positive 2, but you also get a negative 2. They both are the square root of 4. So when that happens, this whole existence of a positive and a negative, we're going to get 2 answers here, a positive and a negative. So what you see very commonly whenever we put a square root in front of a number, so we put it in, didn't come with it, we have to make sure we cover our bases and do both answers. So we're going to have to put that plus or minus in front. Okay, now that we've got the plus or minus, I think we can continue. So on the left-hand side, this squared and this square root, they are opposite operations of each other, so they will cancel. It's actually kind of nice. So if we take a look at this, I still have the parentheses, and I still have the x plus 5. All I peeled off was the squared. Okay, equals. Well, here's the tricky part, and that's why this one was harder. I don't know what the square root of 7 is off the top of my head. I have no idea. I know it's something between 2 and 3. That's about it. So for now, I'm just going to leave it as plus or minus the square root of 7. Now, I am going to grab my calculator near the end of this and actually type it in and get some approximations, but I want to get the exact answer first. Okay, take a look at the left-hand side. I still have those parentheses, which was the next thing to get rid of. But if you take a look at the left-hand side, I don't even think I need them anymore. I really only needed them because of the squared. So I think we can drop those right now. So x plus 5 is equal. I still don't know what that is on that side exactly. So that's the best I can do. Just leave it as it is. Okay, the last thing that I needed to do to try to get the x by itself was to peel off that 5. Well, that 5 is currently being added. So let's go ahead and subtract it. Now, I don't know what the square root of 7 is, so I'm just not going to stack the 5 underneath it because I can't subtract it. Remember, square root of 7 is 2 point something. I don't even know what the something is. So now, let's go ahead and drop our x straight down. We know that the 5's cancel, drop the equal sign. Now, I can't add or subtract those two things because I don't know what the square root of 7 is. So I'm just going to drop it straight down. So plus or minus the square root of 7. And then after it, clearly not inside the square root with the 7, I'm going to put the minus 5. Now, what you could do, and actually I'm a big fan of this myself, I actually rewrite it. I want the negative 5 to come first. And I'll tell you the reason why. I am always afraid I'm going to get sloppy with my writing, and I put the 5 inside the square root with the 7. I know me. I know that's something that I would do. So I basically just switch them around. So, because I don't want the 5 inside. Now, with this is technically the answers. Those are the exact solutions. So these are exact. However, we do want to get some approximates. Well, to get the approximates, I'm actually going to have to grab my calculator. I don't know what they are. Plus, in your calculator, you don't have a plus or minus sign. We're actually going to type them in separately. So we'll do negative 5 plus the square root of 7. And let's go ahead and type that in, get our approximation here. So we got negative 5 plus the square root of 7. This is approximately negative 2.354. Yeah, I would have never guessed that. Definitely not if I subtracted the 5 and the 7 on accident. Okay, but now I got to go to the other one. So negative 5 minus the square root of 7. Approximately. All right, let's type that in. Negative 5 minus the square root of 7. That's going to give me negative 7.645 or 646 if you decide to round. So these are also the solutions. It just kind of depends on what I'm being asked. If I wanted the exact solution, well, then I'd give them the exact solution without actually grabbing my calculator. If I wanted to give them the approximate, okay, then I grab my calculator and type both of them in separately. Okay, last thing for us to review here, and this is the idea of being able to simplify a radical. And I believe this is something that you guys do back in Math 6 or Math 7, so this is just going to be a little bit of a review. All right, a couple of different ways to do this, and I'll do the first two different ways. One way to do it is to actually make a prime factorization tree out of this. So I'm going to take the 50, and I'm just going to try to factor it down. Well, I know that 50 is, 5 times 10. That's one way to do it. Or you could have done 2 times 25. Then I'm going to keep going. Remember, you keep making the tree branches until you get to all prime numbers. As a reminder, a prime number is only divisible by 1 in itself. Well, I think I'm done. All I have is prime numbers now. So I've got a 5, and a 2. Okay, so here's what I'm going to do. I'm going to take that square root of 50, and I'm going to rewrite it as still the square root, but now I'm just going to write the factors out. So I've got a 5, and a 2. Don't actually multiply them. That'll turn it back into 50. Okay. We just experienced in practice the fact that the square root and a square cancel each other out. So I want to see if I can partner anything up using squares. Well, I think I can. It's 5 times 5 is 5 squared. So let's rewrite that as 5 squared. But I still have that times 2. So I'm just going to kind of carry that along with me. Now, one of the things that's really nice, if you have everything inside a square root is being multiplied. Doesn't work if it's add, subtract, multiplication though. If everything inside is being multiplied, we can actually separate them out. So this would be the square root of 5 squared times the square root of 2. Now let's see if we can simplify, because I do see this square root business on the first one. So that square root and that square are going to cancel. So all I have left is the 5. And then I don't know what the square root of 2 is. So the best I can do is just write the square root of 2. Now, you just push them together. That is the simplified version for the square root of 50. Okay, now the next one. I did say that I would show you a couple different ways. Another way that you can do this is you can hunt perfect squares, but you got to be really comfortable with perfect squares to do this. So perfect squares, I'll put mine off to the side. I know that my perfect squares are 0, 1, 4, 9. So this is what I mean by being comfortable with them. You want to be able to identify your perfect squares pretty quickly, and you have to be fairly adept at division. I'm not saying that you shouldn't do it this way. And honestly, I only do it this way if it's obvious to me. And this one's obvious to me because I know a perfect square that goes into 27 evenly, and it's 9. So what I can do is I can rewrite this as the square root of 9 times 3. Now, if there were other factors, I wouldn't necessarily use them. I want to use the perfect square. I'm going to use the same thing I did just a second ago. If it's multiplication, I can split them. Now, I know that the square root here, now I didn't put the square root symbol here. It came with the question. So I'm not going to put a plus or minus in front of it. So I'm only going to do the sign that was given to me. There's no sign there, so the assumption is it's positive. So that's 3. And then other than that, I don't really know what the square root of 3 is. 1 point something. And then just push them together. That is the simplified version of root 27. Why don't you see if you can do 54? You choose your method and then come back and check your answer. So for this one, I went ahead and made a prime factorization tree, but you didn't have to. I know that 54 is also 9 times 6. And 9's a perfect square. So I could have gotten straight to the answer with 3 root 6 as well. Okay, but understand you get the same thing. I did decide to go this path because I wanted you to see how I broke it up. So if you take a look at the tree, yeah, I have 3 3s, but I'm doing square roots, so I want squares. So although I had all of these extra 3s, I just went through and paired them up. So I took those 3s in blue, and I crushed them together as a 3 squared. And then I had that other 3 just kind of hanging out. So I left that 3 by itself. It didn't have a partner, so I didn't group it up. And then I had the 2 also didn't have a partner, so I grouped it up. It's just the whole idea of this partnership business. So then went through and broke them out. So you can see that I've got my square root of 3 squared, which I then square rooted and gave me my 3, because the square and the square root cancel. Then if you take a look at the square root of 3 and the square root of 2, well, I don't have any idea what those are. I mean 1 point something, but that's about it. And then, so I just kind of carried them with me. But what's interesting to note here is that if you have a whole bunch of things strung together on the outside of square root symbols and it's multiplication, you can multiply them. Same rule applies for stuff inside though. So if the 3 and the 2 are both inside the square root and they're still being multiplied, then you can actually multiply them to get 6.